The negation of a statement P is the opposite of the statement. The symbol is this squiggly hyphen, which I believe is called a tilde, and then P. We read that not P. The negation of the statement, the sky is blue, is the sky is not blue. You can use negations to write statements related to a conditional. Every conditional has 3 related conditional statements. Take note, key concept, related conditional statements. In this table, we'll see a statement on the left, followed by how to write it, symbols for a symbolic form of the statement, how to read it, as in how to pronounce it out loud, and finally an example. First, the statement conditional. How to write it? Use the given hypothesis and conclusion. You have some practice with this. In symbols, we write P implies Q using that arrow to stand in for implies. How to read it? If P, then Q, or P implies Q. An example, if the measure of angle A equals 15, then angle A is acute. Next statement, converse. How to write it? Well, we simply exchange the hypothesis and the conclusion. In symbols, this looks like Q implies P. How to read it? If Q, then P, or Q implies P. An example, if A is acute, then the measure of angle A is 15. Recall, not all conditional statements are true. Next, the statement inverse. How to write it? Negate both the hypothesis and the conclusion of the conditional. In symbols, not P implies not Q. How to read it? If not P, then not Q. Or not P implies not Q. An example, if the measure of angle A is not equal to 15, then angle A is not acute. Finally, the statement contrapositive. How to write it? Negate both the hypothesis and the conclusion of the converse. In symbols, this looks like not Q implies not P. How to read it? If not Q, then not P, or not Q implies not P. An example, if angle A is not acute, then the measure of angle A does not equal 15. Below are the truth values of the related statements in the Take Note box. Equivalent statements have the same truth value. First, the statement, the conditional itself. If the measure of angle A equals 15, then angle A is acute. Its truth value? True. The converse of that statement. If angle A is acute, then the measure of angle A equals 15. And this is false. We could find a variety of counterexamples, but it only takes one to prove this statement false. The inverse of the statement. If the measure of angle A does not equal 15, then angle A is not acute. Also false. You should have no trouble finding a counterexample to prove this statement false. Finally, the contrapositive. If angle A is not acute, then the measure of angle A does not equal 15. And this is a true statement. A conditional and its contrapositive are equivalent statements. They are either both true or both false. The converse and inverse of a statement are also equivalent statements. Problem 4. Writing and finding truth values of statements. What are the converse, inverse, and contrapositive of the following conditional? What are the truth values of each? If a statement is false, give a counterexample. Our conditional. If the figure is a square, then the figure is a quadrilateral. In this problem, we'll see what you might think on the left and what you may write on the right as you work through the problem. First think, identify the hypothesis and the conclusion. And write P, the hypothesis, the figure is a square, and Q, the conclusion, the figure is a quadrilateral. Next think, to write the converse, switch the hypothesis and the conclusion. So we'll write Q implies P, or the conclusion implies the hypothesis. The converse is, if the figure is a quadrilateral, then the figure is a square. The converse is false. We can provide a counterexample. Any rectangle that is not a square is a counterexample. Next think, to write the inverse, negate both the hypothesis and the conclusion of the original conditional statement. So we'll write not P implies not Q. And then on the right, you'll write the inverse. If the figure is not a square, then the figure is not a quadrilateral. The inverse is false, and here are some counterexamples. Next think, to write the contrapositive, negate both the hypothesis and the conclusion of the converse. So we'll be writing not Q implies not P. And on the right, we'll write the contrapositive. If the figure is not a quadrilateral, then the figure is not a square. And, like the original statement, the contrapositive is true. Your turn. What are the converse, inverse, and contrapositive of the conditional statement below? What are the truth values of each? If a statement is false, give a counterexample. And the original conditional, if a vegetable is a carrot, then it contains beta-carotene.